Okay, so again, talking about a coordinate plane, and three names really. You can call it a coordinate plane, you can call it a rectangular coordinate plane, or you can call it a Cartesian plane. And as we just went through, and I didn't start the recording, the x-axis is the horizontal axis, the y-axis is the vertical axis. What do we call the point where those two axes intersect? So you can see the red axis intersecting the green axis, and two people know. How many others you think you know? Let me see your hand. What that point is called. So 3, maybe 4. All right, girls on 3. 1, 2, 3. You have your hand up. Give me your answer. 0? No.
The origin?
It doesn't begin with an O. It is the origin. Very good. It just popped right into Christina's head. Like, bang, there it was. Yeah, and, origins is the idea of beginnings, and it is the key point in a coordinate plane or Cartesian plane. It is the intersecting of the x-axis, the horizontal axis, and the y-axis, the vertical axis. Now, you can see that by having an x and y axis, we break up the plane into 4 regions. Now, if you play some army games and stuff, you might know what the technical name is for these regions. They're called quadrants. Quadrants. Right? So the Cartesian plane is broken up into 4 quadrants by the x and the y axis. Well, everyone needs to know where quadrant 1 is, where quadrant 2 is, where quadrant 3 is, and where quadrant 4 is. And to make things more fun, we use Roman numerals for our quadrants. And you must use Roman numerals. Now look, all right, if you're going to say 59, that could be challenging. But 4, that's pretty easy. 3 is easy. 2 is easy. 1 is easy. So shouldn't have any problem there. Yes, ma'am?
I just need to clear something up with Omar. Is he in there right now?
Okay, so every student does need to know where the 4 quadrants are. So let's take a look. Don't say anything. You got upper left, upper right, lower left, lower right. And what I need to know is where you think quad 1 is. Upper left, upper right, don't say anything yet. Lower left, lower right. And that's what you're going to say to me on 3. You're either going to say upper left, you're going to say upper right, lower left, lower right. All right, on 3. Here we go. 1, 2, 3.
Right.
So the boisterous ones were upper right, and that is correct. Quadrant 1 is the upper right quadrant. So I just use Q for quadrant and Roman numeral number 1. You might ask, why is that quadrant 1? I'll explain a little bit more when we do coordinates. But there's also a tie-in to angles. An angle in standard position in trigonometry has one ray, don't draw this in your notes, along the positive x-axis, and they begin to open up counterclockwise. That would be a 45-degree angle. If the terminal ray were to go all the way to here, that would now be a 135-degree angle. And you see how the opening's getting larger and larger as you go around? So quad 1 is definitely there in the upper right. So according to what I just did, where's quad 2? Upper left, bottom right. Those are really the only 2 logical choices. Upper left, bottom right. Give me your choice. 1, 2, 3. It is the upper left, because again, as you saw the way the angle opened, it goes from quad 1 to quad 2. That makes quad 3 the lower left, and quad 4 the lower right. So you got quad 1, quad 2, quad 3, quad 4. So, here's a map. Treasure Island. Ooh, yeah. And what we want to talk about some are the aspects of coordinates. This map has a set of coordinates to locate things. Now, people don't look at maps hardly anymore. I mean, it used to be in everybody's car, they had a physical map of like Virginia, a map of the eastern United States. You know, if you were going to go out west, you would get maps so you'd know what roads to go on. Now you punch it in your phone or punch it in your GPS, and nobody has any earthly idea where they're going anymore. But anyhow, that's a whole other story. All right, you have no idea where you're going. You know, kids, we're going to Wisconsin today. Okay, great. You get in the car and you go. You don't know if you're going north, south, east, or west. You have no clue. You're just following the little thing on the screen. All right, good, cool. But maps also have a grid system or coordinate system, and so the coordinates are used to locate objects. So let's, how would you classify, let's do the windmill. What would you call the coordinates of the windmill? All right, now you got to look and find the windmill, and it would be the base of the windmill. And what would be the coordinates of the base of the windmill? What do you think? Chloe, what do you think? 44? Speak up for me. No, never mind. Not allowed. Oh, gotcha. Quadrant 4, I think, is what you're saying. Okay, I'm sorry. Not quite the idea, Chloe, and that's okay, because, you know, we have to think and we got to try, and that's how we learn. So not a problem. Brendan, what do you think are the coordinates of the windmill? 2, 6. Okay? Anybody agree with Brendan? All right? Anybody disagree with Brendan? Uh-oh, we have dissension here. Kristen, what do you want the coordinates of the windmill to be?
6.
Okay, she went opposite. So Brendan says 2, 6, and Kristen says 6, 2. So let me check in. How many are 2, 6? It was a bunch of you, right? Okay, and how many 6, 2? So the majority looks like is 2, 6. So it's got to be 2, 6, right? Because the majority is always right. Let me ask you something. This axis right here along the bottom, which one would it be? Which one is it? X. Okay, I agree. And this axis going up here would be the what? Y. Okay, so let's see what Brendan did and let's see what Kristen did. Brendan said from here to, right? And then 6, yes? So Brendan said 2, 6. So Brendan said Y, X. And Kristen said 6 first, X, and Y second, 2. So don't say anything. I just want to know if anybody wants to convert from 2, 6 to 6, 2 or 6, 2 to 2, 6. Any conversions? Let me see your hands. All right, so let's vote again. How many say 2, 6? How many say 6, 2? All right, good conversions there. Right, and you see obviously why X comes before Y. It's always the X coordinate first and then the Y coordinate second. So yes, the coordinates of the windmill are 6, 2. Now look, it's easy to locate stuff. If I said, what is that? I got to make sure I know what in the world a shape is. If I said, I can't tell for some of these. If I said, what is that coordinates 8, 5, what would you say? Don't say it out loud. What object is that coordinates 8, 5? And you would say the sailboat, right? Get the idea? So what are coordinates for? They're to locate things. But look, make sure you get it straight. Because if you go opposite, you're going to be wrong, right? If you go the wrong way, if I say coordinate 4, 5, I get that building, right? But if I say 5, 4, I get nothing. So it just depends. So what's the lesson? The lesson is you have to go in the correct order. So if I say coordinates 4, 2, 4, 2, you say, right, the brick wall, it looks like to me. I think it's a brick wall. All right, the octopus is easy, 1, 1. and everything else you got to figure out. All right, so here's our Cartesian plane, coordinate plane again. You know what? I don't even need that shade. Let's see. I think I'm going to shrink this a little bit. Let me pause for a second. Okay, so here we've got a Cartesian plane, and this is normal algebra. Now we've got some points, and we've got a letter associated with the points, so we know which point we're talking about. All right, before we get there, let's fill in number 3. Points are located in the plane by a pair of ordered, and then comes the word coordinates. C-O-O-R-D-I-N-A-T-E-S. C-O-O-R-D-I-N-A-T-E-S. A pair of ordered coordinates. Now, you might say, why use the word ordered? For the reason we just did a minute ago with figuring out the windmill. Was it 2-6 or 6-2? Well, we got to have an order to this thing. There's got to be order, otherwise we'll never know. And so there's an order, the x first, then the y. The x coordinate first, the y coordinate. So, for that reason, the first coordinate is always the x coordinate, as we just found out. Now, I don't know if Christina or Kristen, you guys remember the name of every x coordinate. It begins with an A, and it's not a common word. All right, it's called, each x coordinate is called an abscissa. A-B-S-C-I-S-S-A, an abscissa. Every x coordinate is an abscissa. Of course, every second coordinate is always the y coordinate. Gee, that's hard to remember. Alphabetical order. X comes before y, all right? And each y coordinate can be called 2 different things. Now, the first name's pretty easy because it's a form of the word coordinate. It's a form of the word coordinate. Edward?
Coordinate.
Good try. All right, Kristen? You're co-off, so you got to drop the co. Actually, it's ordinate. O-R-D-I-N-A-T-E. You drop the co. So drop the co off the word coordinate, and you get ordinate. O-R-D-I-N-A-T-E. Ordinate. Drop the co, and there you are, ordinate. However, the y has 2 names. Not only is it called the ordinate, it can also be called the image. You guys remember back to the image and pre-image? So the second one being the image, and sometimes we call this second, the y coordinate, the image. So either way, ordinate or image. So those words aren't normal words. You're going to have to review those and remember those. Come a quiz or something, right? I mean, what is every x called? An abscissa. Yeah, everybody usually has that in their vocabulary. Again, ordinate's not so bad. And C, the point with coordinates 0, 0 is called the origin. Right? The origin. Because what point has coordinates 0, 0? So let me pause for a second and make things clear. That point right there at the center, and I just made a blue point, the place where the x and y axes both intersect have an x value of 0 and a y value of 0. The first block to the right on the horizontal number line is 1, right? You go from 0, then first block 1, next block 2, etc. The other way, -1, -2, going up, first block 1, second 2, etc. Going down, first block -2, next line, or -1, next line -2, etc. Going down, not a big deal. All right, so number 4, locate each point in the Cartesian plane above. Label the point with its letter. All right, so I want you to go through and put in a point A, So do it, I already have some points there. Do it just like those points are. Put the point right at the intersection of the coordinates and then put the letter by it. So put point A by 5, 2. Put point B at the coordinates of -3, -2. And put point C at the coordinates of 0, -3. All right, so point A went at 5, 2. So I should have gone, don't draw this in your notes, 5 to the right and 2 up. And isn't right there the intersection of 5 and 2? That's an x-coordinate of 5 and a y-coordinate of 2. And the A should be right there. How many got that one right? Okay. So the second one, -3, -2. I have to go to an x-coordinate of -3 and a y-coordinate of -2. So the way I do it, I go left 3 and then down to the -2, right? Go to the x-coordinate -3, then down to the -2, and that's point B. And how many had that in the correct location? All right, good. And then the third one, 0, -3. So listen, how much horizontally are we going from the origin? We're not going any, 0, right? But we are going -3, and -3 is the y part, so that's down, right? You see what happens on our Cartesian plane? Think about the horizontal part first. If you have a positive x-coordinate, which way are you going from the origin? Positive x-coordinate. Which way do you go from the origin, left or right? Okay, so watch. Everybody thinking now. Look up at the screen. Here's the origin right here, yes? If I have a point with a positive x-coordinate, which way does that point go? Right or left? Correct, because positive numbers are to the right of the origin and negative numbers are to the left. So a positive x goes right and negative x goes left. Now with the y from the origin, a positive y goes which way? Positive y goes which way? Up. And a negative y goes down. So when we just did B, we did -3, I got to go left. And then I got to go -2, I got to go down, and I get that point there of B. And so our last one here that we're doing, C, 0, -3, I don't go left or right any. And I go down 3, so C is right there on the y-axis at 0, -3. Now, how many got C correct? Not as many, and those are the trickier ones, but look, once you get the idea, it's not hard. Okay, go ahead and do the last 3 questions. What are the coordinates of K, L, P, and Q? I'm going to do mine up here so I can still have the screen showing. K, L, P, and Q. Make sure you use proper notation. All right, let's see. I'm going to pick on people. Hayden, what do you got for K? How many agree with Hayden, -4, 2 for the coordinates of K? And those would be the correct ones. Did you put yours in parentheses? Did you put a comma between the X and Y? That's proper notation, right? Parentheses, comma between the X and the Y. Hannah, why don't you do L for me? How many agree with Hannah, -2, 0? And that is correct. -2, 0. Emily, why don't you do P for us? How many agree with Emily, 2, -4 for B? And that would be correct. And who wants to finish up with Q? Who's my Q? Nia, go ahead. Give me Q.
2, 3.
How many agree with Nia, 2, 3? And that is correct. All right, so let me just recap real quickly. Coordinate plane, rectangular coordinate plane, or Cartesian plane, they're all one and the same. They involve a horizontal axis called the x-axis and a vertical axis called the y-axis. Where the two axes intersect is a point with coordinates of 0, 0, and we call it the origin. Okay? Points can be located in the Cartesian plane by their set of ordered pairs called coordinates. The x is always listed first. The y is always listed second. Every x coordinate is called an abscissa. So look at the screen. Look at the K, L, P, and Q points off on the right. So -4 is an abscissa, -2 is an abscissa, and these 2's are abscissas, right? Every x coordinate is an abscissa. Every y coordinate is an ordinate or an image. So 2 is an image, 0 is an image, -4 is an image, and 3 is an image. And we'll build from here with our math. All right? All right, that's it for today's lesson.